milliseconds, delivering all of its energy in doing so. And you produce an enormous explosion. The amount of energy that is released in this event is more than enough to evaporate the world's oceans.
A massive asteroid from outer space heads straight for Earth. It's as large as the one that impacted over 4 billion years ago. This computer simulation has been made with the scientific advice of geophysical experts to show the effects if the impact were to happen today. The asteroid's diameter is larger than the main island of Japan. Even though it is moving at over 720,000 kilometers an hour, that's almost 450,000 miles an hour, the asteroid appears eerily slow because of its size. The actual impact happens in the Pacific Ocean, just under 1,000 miles south of Japan. The crust of the Earth is peeled away like an orange skin by what is called the crest tsunami. Even the deepest part of the Pacific Ocean looks like a thin film. Huge chunks of debris the size of city blocks are hurled into the air. The entire Japanese archipelago is disintegrated, as is some of the Asian continent. The shattered remains are hurled out into space way beyond the atmosphere to bombard the Earth with deadly intent when they re-enter. At 7,000 meters, 23,000 feet, the rim of the crater is higher than many mountains on Earth today. The size of the crater would be a distance of 2,500 miles or 4,000 kilometers. And this is just the start.
When an asteroid hits the surface of the Earth, the material is heated up to temperatures that get up to the point of, say, 4,000 to 6,000 degrees centigrade. This is as hot as the surface of the sun. When an impact hits, it's not just the crater that forms, it's not just the area where the impact occurred. It's all the heating that's created in the atmosphere and around it. So heat really is the killer.
Moments after the impact, rock vapor, the temperature of the sun, begins to engulf the world. Could any life at all survive this impact? Immediately after the impact, the rock vapor rises up from the crater in a dome, then spreads out in all directions across the globe. 3 hours after the impact south of Japan, the expanding wall of vaporized rock reaches the mountains of the Himalayas. The perpetual snows are instantly evaporated. Soon the wall of fire reaches the Amazon, the furthest distance from the point of impact. The forest spontaneously combusts even before the rock vapor arrives. Just one day after the impact, the entire planet is covered. Every living plant or creature is vaporized. It's been estimated that this vapor would cover the entire globe for almost a year. It would be as if the sun had come to Earth. The ocean would start to bubble and boil, and as the water evaporates, the oceans would drop at the rate of 5 centimeters or 2 inches every second. Even the salt deposited on the ocean floor vaporizes, and then the very bottom of the sea melts. Nothing is left untouched. One month after the impact, the surface of the world has been sterilized. The oceans have vanished. All that remains is the superheated bedrock. It is thought that an impact like this happened 6 times in the violent past of the Earth's history. If there was life, it was assumed that it too would have been wiped out, only to begin again.
When you have an impact, you have that instant in which all this energy is converted to heat. But that's only part of it. You then have the vapor that expands and heats up the atmosphere as well. So now you are no longer dealing with just the point of impact and the vapor that's created there. You now have material that is expanding. Eventually, some of that material is expanding and goes out of the atmosphere of the Earth, then comes back down. During the time when it comes back down, it's generating more radiation, so that you have the heat of the impact, then you have the material, the vapor that heats the atmosphere, then you have ejecta that returns to the surface of the Earth. And as it goes through the atmosphere, it will create enough energy to literally fry, completely combust any living organism that would exist.
The total evaporation event that occurred around 4 billion years ago was catastrophic. Water as well as salt deposited on the ocean floor evaporated. There are microbes that actually like heat, but not heat like this. Immediately after the impact, the planet would have looked like a fireball. But within only a year, the rock vapor would start to dissipate and temperatures would begin to drop. Because of the Earth's size and gravity, the evaporated water would not escape into space, and within only 1,000 years, the water vapor would cool and condense, and then fall back as torrential rain. Once again, the oceans would start to fill. Once again, the oceans would start to fill.